In this video, we will show the sequence of actions to observe how a wind turbine passes from stop state to production, operation known as cut-in. Execute the launcher by pressing the ACM-SL icon on the desktop. On the left panel of the launcher form, search for the Wind Turbine Simulator's blue line and press it. In the drop-down list, select the first option. It corresponds to the simulator for a squirrel cage generator controlled by blade stalling. The synoptics of this simulator will start popping up. Finally, the tutorial will be at the top. In the tutorial, we will look for the teaching sessions. We find many suggested experiments. We click on the first one, titled, Setting the Conditions for a Wind Turbine to Start Operation with Low Wind Speed. It describes the steps to follow in the simulator user interface, so that the wind turbine passes from stop state to production. We will follow these steps for the cut-in process. For that, it is handy to have a second screen to place the tutorial to read. We must locate the Executing Synoptic upper left corner and press the Run button. Now the simulation is running, and the variables take their initial state values. As a result, the blade's pitch angle moves to -90 degrees. You can observe its evolution on the synoptic drivetrain and in the synoptic wind nacelle. Also, the controller presents three opened incidences. The first two, undervoltage and grid phase failure, are related to the connection of the power cables with the electric grid. Immediately after, the controller is informed that these incidences are recovered, and their state are immediately displayed, indicating when that happened. Time is displayed in the format: year, month, day, hour, minute, second, and milliseconds. In general, the incidences related to the electric power system, after recovering, must be acknowledged by the local operator. That is, it can't be done remotely from the SCADA system. So we must click on the checkboxes corresponding to the incidences. After that, they will pass to the Historic Incidences tab. At this moment, there will be only one open incidence, named Manual Stop. It indicates that the wind turbine was properly shut down, or that it never was in production. In this situation, any operation that requires a power connection is operational. For example, pressing the yawing buttons in the control terminal will change the orientation of the nacelle accordingly. Following the indications of the experiment, we will change the wind speed to 6.2 meters per second. Using the page down and down arrow keys, notice that the blue arrow in the left panel of the synoptic wind nacelle is proportional to the actual wind speed value. Also, notice that the effective wind speed, indicated in the control terminal synoptic, is lower due to the nacelle's misorientation with respect to the wind direction. The blue vector located at the edge of the blade, in the right panel, is also proportional to the effective wind speed. In this situation, we can send the command of start to the controller. For that, press the Start button in the control terminal. In the opened incidences, this instant is presented in the Recovered column. To continue, acknowledge it, mark the checkbox in the Acknowledge column. After that, several actions take place. The nacelle gets oriented to face the wind direction. The blade's pitch angle moves to 0 degrees. After some time, the drivetrain brake is liberated, and consequently the hub starts rotating. You can observe the evolutions of the signals corresponding to the braking system looking to the nacelle internal view. The buttons associated with the pump, valve, pressure switch, and hydraulic pressure indicator are located conveniently near their symbols in the synoptic. Brake liberation happened after the hydraulic pressure got above the red signal. The associated lights indicate the status of the pump, pressure switch, and brake valve. When the generator RPMs arrive to its synchronous speed, 1000 revolutions per minute, the indicator of the thyristors activation lights, and shortly after the bypass indicator lights and thyristor lights goes off. At this moment the generator is connected to the grid and producing electricity, 193 kilowatts. The controller also informs us it uses the small generator, as the wind speed is in the low range, compared to the nominal value, which is around 15 meters per second. So far we have achieved our target. The wind turbine is in production. Now, we may question ourselves, it would be good to see how has been the evolution of key signals. The simulator provides a specific type of synoptic, known as panels, that contains sets of strip recorders. Each one of them presents the evolution of one or more signals. These signals may be analogical or digital. Each signal has an associated color, and the header of each strip recorder contains the names of its signals. Each panel has a time base at the top. The representation moves leftwards, and its speed is selected using the timer per pixel button. The actual date time is indicated in the right part of the time base. The button hard copy creates a frozen view of the panel at the instant it is pressed. Its main interest is to observe the evolution of the signals in a relaxed manner. It contains a time course line that traverses all the strip recorders, so it is very easy to check how the evolution of each signal compares with the other signals. For example, the moment I press the Start button corresponds to the beginning of change of the pitch angle. Look to the blue signal at the top script recorder. Setting that instant as time reference, we can measure the time any other event has happened. Observe the hydraulic braking system sensor, green signal in the third strip recorder, is not liberated immediately. Rather, that release happens when the pitch angle arrives at some value. That has to do with the controller's algorithm to test that the hydraulic system does perform properly. When the brake is released, the blades start rotating. Look at the acceleration of the drivetrain RPMs. There are two regions. Eventually, the RPMs reach the vicinity of the 1000 value, the synchronous speed of the small generator. This is a key moment. The generator axis is rotating near its synchronous speed, and its stator winding is disconnected from the grid. For production, the conditions are as follows. The stator must be connected to the grid, the RPMs must be above synchronous speed, and there must be a rotating magnetic flux in the air gap. This transition is handled by a specific device, known as soft starter. Read the tutorial for a detailed discussion about it. Once you are familiar with the Cutin operation of the wind turbine and how to observe the key signals in the synoptic and panels, we strongly recommend you to read the tutorial and practice with other key experiments, like the one shown in the slides.